All right, hello everyone. Welcome to my channel. This channel is for educational purposes, usually trying to shed light on difficult and obscure theories that, if they were well known, would be revolutionary. But the powers that be have suppressed them, and you don't know anything about them. So I'm trying to put them out there. I stumbled into them, some of them from just doing some digging, and one of them is Dewey B. Larson and his reciprocal system of theory. And this is the 203rd video that we've done on the reciprocal system. And we are looking at his 1979 book called Nothing But Motion. And that is the essence of Larson's reciprocal system of theory, is that we live in a universe of nothing but motion. It is not a motion of, it's not a universe of matter, not a universe of energy, but a universe of motion. And for Larson, motion is the relationship between space and time. So that makes space and time not the container of the universe, but the contents of the universe. The universe is made out of space-time. Motion is a fraction where space and time, space or time, is the numerator, and time or space is the denominator. All kinds of scientific phenomena and mechanical phenomena are can be strictly expressed in exclusively time-space terms. But as time and space are reciprocals of each other, they basically have identical qualities. And one of those qualities is that they are coordinate. There is coordinate space, which we are familiar with, 3 or more dimensions of space. But there is also coordinate time, 3 or more dimensions of time. And there is clock time, which we're familiar with. The clock is always getting later and later and later, and it's progressing in no particular direction. And there is also clock space. Space is always getting farther and farther and farther apart, but in no particular direction, or really in all directions. And you can envision this by taking a balloon, putting a bunch of dots on it with a magic marker, and blowing up the balloon. All of the dots are moving away from each other. It was also can be based on the Hubble telescope, which noted that all of the distant galaxies are moving away from each other, but again in no particular direction. Also, space and time come only in discrete units. There is no continuity of space and time. They come in chunks, and one chunk of space in one chunk of time is the speed of light. So the speed of light is 1 over 1 equals 1. And that makes its speed of light the midpoint of the universe. Unlike Einstein, which Einstein says that the speed of light is the maximum speed of the universe. That's because Einstein only knew about one of the 2 main sectors of the universe, which Larson calls the material sector and the cosmic sector. In the material sector, everything is moving slower than the speed of light, and therefore the speed of light is the maximum speed of the universe. But in the cosmic sector, everything is moving faster than the speed of light, and the speed of light is actually the minimum speed of that universe. And in that universe, we have in the material sector, we have what we're familiar with. This material sector is where we live and where we make our observations. And In the material sector, we have coordinate space, three-dimensional space, and clock time. Time is always progressing or flowing and getting later and later. But in the cosmic sector, we have the exact inverse of that, which is basically inverting the roles of space and time. So in the cosmic sector, we have coordinate time, three-dimensional time, and we have clock space. Space is always progressing, getting farther and farther apart. So not only does that enable us to extrapolate what's going on in the material sector to discover what's going on in the cosmic sector, even though it's beyond our ken of observation, but we can do that generally for everything. So we can basically double our understanding by understanding what exactly is going on in the cosmic sector. And Larson has written books on this, and this chapter here that we're working on, chapter 15 of this book called Cosmic Ray Decay, is part of that. But in general, Larson describes the cosmic sector as being primarily about consciousness, language, and that you really kind of want to envision that the material sector and the cosmic sector both exist in the same space, but they are like out of phase. And so we have, a brain that exists in the material sector, but we have a mind that exists in the cosmic sector. Okay, now let's try to get into Larson. Now he's talking about cosmic rays and cosmic ray decay. Cosmic rays are basically cosmic atoms, the inverse of material atoms. For Larson, material atoms were combinations of motions. You start out with a photon, which is a simple harmonic motion, a wave. And that wave is a combination of two motions. So you have a translational motion, you have a vibrational motion, you have a rotational motion, and you have a rotational vibration. And those motions can be multidimensional as well, but they are the basic building blocks for building up an atom. And so at the core of all the atoms is one or two of all matter is one or two photons, and the photons are comprised of a combination of a translational motion and a vibrational motion in the opposite at 90 degrees of the translational motion. So when you combine them, you get a sine wave or a simple harmonic motion. Now, many of Larson's followers disagreed strongly with that, including KVK Nehru, who wrote the article that is called The Photon as a Birotation. So Nehru believed that the photon came from two counter-rotating motions, and when you combine those two, you get also a sine wave. So that is something that kind of has to be sussed out over time. To me, I think that Nehru's theory is better, but I'm not sure about that. We will be going over Nehru's theory as we go through this a little bit more, but first we want to look at the original source, which is Larson. So we're gonna just humor the whole thing with his idea that the sine wave comes from a translational motion and a vibrational motion in the opposite, 90 degrees out of phase. And then that's at the core of the atom. There's most likely going to be two of those for an atom. And then when those are rotated, they become atoms. So atoms are a combination of two-dimensional rotations, and then an optional one-dimensional rotation. Um, and then cosmic atoms are going to be the opposite of that. Basically, uh, the photon is going to be in space or time, and then the rotation is going to be in time or space. And so the reverse of that is what the cosmic atom is. But the cosmic atom enters the material when the cosmic atom enters the material sector as a result of a powerful explosion, generally, usually of a star or galaxy. Then it comes into the material sector where it is not stable because it doesn't have the elements of stability for that region because of its inverted nature, and so it immediately begins to decay or become radioactive, and it decays into different particles in a fast decay sequence, and then settles in as really two massless neutrons. And so that is what the end product of the cosmic ray decay is. Now, Larson's going to go through this process as we read along here. In the first edition, it was recognized that the incoming cosmic rays would consist primarily of cosmic hydrogen. But at that time, there were no observational indications of any cosmic ray particles in the hydrogen mass range, and the extension of the theoretical development to the questions of scalar motion in 2 dimensions and the lifetimes of the cosmic atoms had not yet been undertaken. The exact theoretical status of the incoming C hydrogen or cosmic hydrogen atoms was therefore still uncertain. Inasmuch as the mesons then known were mainly cosmic elements of the inert gas series, meaning the noble gases, the cosmic noble gases, it was concluded that the original C hydrogen atoms must be stripped of their one-dimensional rotation and reduced to the two-dimensional or inert gas condition almost immediately on crossing the speed boundary. In the meantime, however, the investigators have been able to extend their observations to earlier portions of the decay path, and they have recently discovered a short-lived particle with a mass that is reported as 3,695 mega electron volts. Identification of this 3695 psi particle, PSI particle, as a cosmic deuteron with 2 material isotopic charges by Ronald W. Satz was the crucial theoretical advance that opened the door to a clarification of the status of cosmic hydrogen. This now enables us to close the gap and trace the progress of the cosmic atom from its entry into the material sector in the form of cosmic hydrogen, that being cosmic deuterium, not hydrogen 1, but hydrogen isotope 2, all the way to its final transformation into material particles. For reasons which will be explained in Volume 2, the cosmic atom has an effective translational motion in 2 of the 3 scalar dimensions at the neutral point where it enters the material half of the universe. The terrestrial environment into which the observable cosmic atoms enter is favorable for the acquisition of gravitational charges of the material type. Each of the 2 dimensions of motion, therefore, adds such a charge. The 2 charges acquired by the C deuterium, the cosmic deuterium atom, add 1,862.3 megavolts to the 1,848.6 megavolt mass, mega electron volt, mass equivalent to the cosmic mass, bringing the total mass of this, the first of the theoretical cosmic ray particles, to 3710.9 mega electron volts. The mass of the newly discovered psi particle is reported as 3695. In view of the many uncertainties involved in the observations, this can be regarded as consistent with a theoretical value. Okay, now, yesterday, Larson went through a discussion of how you calculate these mega electron volts. This is really how mass is calculated over in the cosmic sector. So you might want to review yesterday's video if you want to get a derivation of how Larson comes up with these numbers here. Basically meaning that he's not just pulling them out of no place. As mentioned earlier, the particle lifetimes are correlated with the dimensions of the spatial motions that the particles acquire. The translational motion and the gravitational charges. While the theoretical situation has not yet been clarified, we find empirically that the life of a particle with 2 dimensions of scalar motion in space and no gravitational charge is about 10 to the minus 16 seconds, approximately the natural unit of time. Each dimension of motion modifies the unit of time applicable to the particle life by approximately 10 to the minus 8, while each gravitational charge modifies the unit by about 10 to the minus 2. On this basis, the following approximate lifetimes are applicable. And so he's saying 3 dimensions and 0 charges, the expected lifetime is 10 to the minus 24 seconds. If you have 2 dimensions and 2 charges, then you're talking 10 to the minus 20. If you have 2 dimensions and 0 charges, you're talking 10 to the minus 16. If you only have 1 dimension and 1 charge, you're talking 10 to the minus 10. And if you have 1 dimension and 0 charges, then you're talking 10 to the minus 8. So there's basically 2 factors that are involved. Each dimension you multiply by 10 to the minus 8, and each gravitational charge, which is what creates isotopes. Each gravitational charge is 10 to the minus 2. So if you have something like hydrogen, like Ronald Satz was saying, that the hydrogen with 2 charges, 2 gravitational charges, because it was the, he said it was the deuteron, cosmic deuteron with 2 material isotopic charges. I thought the deuteron was, no, maybe deuteron is hydrogen, well, deuterium is the second isotope of hydrogen. So I'm not exactly sure where Satz is coming from. Maybe we just continue on. We'll get some answers here. The reported lifetime of the 3695 psi particle is in the neighborhood of 10 to the minus 20 seconds, which agrees because it's got 2 dimensions. That's 10 to the minus 16, and then you have to multiply it again by 10 to the minus 4 for the two charges, which agrees with the theoretical determination of the dimensions of motion on which the mass calculation is based. The general decay pattern defined in the preceding pages indicates that cosmic deuterium, H2, should undergo an ejection of positive rotational displacement, converting it to cosmic helium-3 from the expression 3724.61 over m, we obtain 1242 mega electron volts as the rotational mass of CHE3, cosmic helium 3, to which we add the mass of two gravitational charges for a total of 3104 mega electron volts. The observed 3695 particle decays to another psi particle with a reported mass of 3105, very close to his prediction of 3104, and a life of about 10 to the minus 20 seconds. This second particle can clearly be identified with the cosmic helium-3 atom. Thus, the observed masses, the lifetimes, and the decay pattern all confirm the basic identification of the C hydrogen particle by SATs. Another decay of the same kind would produce CHE4, the 4-mass isotope of cosmic helium. And it is probable that some particles of this composition are occasionally formed. Indeed, any cosmic atom between C hydrogen and C krypton may appear in the cosmic ray products. Now, C krypton is at the end of the line of the decay. Once you get to C krypton, then which is 330 in Larson's notation, then it can invert and convert immediately to two massless neutrons. So C krypton is the last cosmic atom involved here. So he's saying any cosmic atom between C hydrogen and C krypton may appear in the cosmic ray products, depending on basically statistics. But the probabilities favor certain specific cosmic elements, and these are the products that constitute the normal decay sequence we are now examining. The speeds of the cosmic rays and their decay products decrease rapidly in the material environment, and by the time the decay of cosmic helium-3 is due, the additional energy loss in the decay process is usually sufficient to drop the cosmic residue into the speed range below unity. The consequent elimination of the motion in the second scalar dimension results in a double decay, which adds 2 atomic weight units to the cosmic atom. The product is cosmic lithium-5. Okay, I guess we're going to stop there for now. Now, this is obviously very, very difficult stuff. Just let it wash over you and put it on the back burner, and just recognize that this is within the scope of Larson's theory, and he's coming up with better solutions than the mainstream scientists are, but it's all pretty theoretical and pretty difficult to follow. I'm actually pretty excited because this is probably the 7th or 8th time I've read this book, but this is the first time that I've even come close to understanding it, this chapter. So, maybe at least if I get a grasp of it, I might be able to explain it better to you. Again, Larson is, I think, a good writer, but he's not a great teacher, and the information is always there, but it's hard to extract it, and the information is usually so difficult and requires a great deal of unlearning of the old principles. And also, Larson is trying to explain something in an entirely new language, so he's having to come up with terminology, notations, and all of these things that, they can be difficult and cumbersome and ambiguous because, he's kind of trying it out. Let's try this notation. Let's try this word for that concept. And they don't always go smoothly. So you have to cut Larson a little bit of slack because he is the originator of this theory, and so he pretty much had to do all the heavy lifting, and sometimes it didn't go perfectly. But the information is there, and now that other people are beginning to learn about this theory, we can work it out. We can work out his concepts to fit in with concepts that we're at least maybe not comfortable with, but maybe at least we're somewhat fluent in them. Okay, now thanks for tuning in and have a great day.